So our final presenters today are from the Universities of Manchester, Dr. Vivek Koncherry and Dr. Shankar Roy, presenting on manufacturing of optimized preforms.
Hello, everybody. My name is Vivek. This part of the talk is about the 3D preform manufacturing for the car floor panel. I would like to show a video comparing the conventional 3D weaving with the multi-weft weaving system we developed at Manchester. This is a conventional 3D weaving, and as you can see from the video, we are inserting single weft at a time. And one of the problem in this technique is fiber damage. Even though you can see that machine is running really fast, the output is very slow. An elegant way to solve this problem is the patented weaving system. As you can see in the video now, we developed this in this SimCom Hub project. We can put 22 wefts simultaneously in this system, and we further modified this robot to incorporate off-axis fibers. We can make near-net shapes as well, such as T's, Pi's, and I. Sorry, next slide. We developed two sets of samples at coupon level to compare the mechanical properties between the conventional 3D fabric and multi-axial 3D fabric. This is sample A. It's a 5-layer 3D structure with fibers in 0 and 90 direction. We use 24K carbon fiber in 0-90 and 6K fiber as a binder. This is a sample B. It's a multi-axial 3D structure with fibers in 0, 90, and plus minus 45. We used a 24K carbon fiber in 0, 90 direction and 6K as a binder. Optimization of the structure is still needed depending on the application. This is a table comparing the fabric structures of A without bias fibers and sample B with bias fibers in 45-degree direction. We resin infused the samples. And on the left side is the cross-section image in warp and weft direction of sample A with bias fibers, and on the right side it's sample B with bias. Sample A do not have bias fibers, and sample B with bias fibers on the right side. From the image, you can see that there is almost no crimp in the stuffer layers in sample B. We perform tensile tests in warp direction and in off-axis direction 45 for both sample A and B. Table 1 and 2 on the top is the tensile modulus and strength in warp direction 0 degrees. There is some drop in the tensile modulus and strength in the sample B with off-axis fibers. But if you look at the bottom tables 3 and 4, there is a significant increase in the off-axis tensile strength and modulus. It's nearly 4 times. It's clear from the coupon test we can optimize the performance depending on the application. As Mikhail showed earlier, this is the demonstrator we are working in this project. This is a car floor panel with AMRC. We already made a 1 meter by 1 meter 3D multi-axial fabric. It's me holding the large multi-axial fabrics we developed at Manchester. We can, using the current system, we can make up to 2 meter wide samples. We are looking for partners to develop a commercial 3D multi-axial robotic system. Just to conclude, we already developed a near-net weaving capability and reduce the fiber damage. We also know that we can improve the off-axis properties. Mikhail and I are working on infusing the first preform I showed you earlier. We will be doing the testing and further optimizing it for the application. I will pass to my colleague Roy to talk more about braiding and winding.